Oh, welcome. Today let's try to solve Leetcode problem 312, burst blues. So this is a really hard problem because basically, let me give you an example. So for this example, the result is 167. I'm not going to explain the example because this is really straightforward. You just need to check if the values is right for the final result of 167 according to different sequence of burning the blues. Now let me give you an example of how to solve this problem. Basically, if we solve it straightforward like the brute force, maybe you will think maybe I can add some paddings. At the left side I add one, and at the right side I also add a padding for just easy for calculation. But if we think straightforward, it means if we burst the first blue, for example, we just need to combine all the combinations. We can choose to burst this one or not. We can choose to burst this one or not, or we can choose burst this one or not. But basically, this is a brute force solution, so it will be n factorial or 2 to the power of n. But basically it's a very large number. You cannot decrease the time complexity. If you think, so for example, you're gonna burn, for example, 3. So after burning of 3, you get a result. For the left side, you can use this one. For the right side, you can use this one. But after burning the first 3, you're gonna have a result of 1, 5, and 8. So this is only one situation. So for this one, you're still gonna choose 1, 2, 3. And then for this one, you're still gonna to use the padding from the left side and the right side. Still use a padding of 1 and 1. Because that is just easy for the calculation. Now you want to make it smaller. Maybe you're gonna burn the 1 first. What about burn the 1? After burning of 1, what you left behind is 5 and 8. Now you still need a padding for the 5 and 8. Now maybe you're gonna try to burn 5 first. So what you left behind is 8. So for this 8, maybe you will use padding or not. It doesn't matter. So for example, you just use the padding. So how many combinations? As you can see, so for the first one, there are 4 times 3 times 2 times 1. It is n factorial. So that is why you cannot pass, because this nums array is very long. It is 300. So basically, you cannot solve it in n factorial time complexity. But you can solve it in n cubic. If you can't solve it in O(n) square, because O(n) square, I didn't find a way to solve it in O(n) square. So there's actually O(n) cubic method to solve the problem. So currently, for our method, we are not going to burst one to another, one by one, according to the brute force. Burst this one left behind, burst this one left behind. We are thinking something differently. Actually, we are thinking about reversely. So what about 3 is our last blue to burst? What about if 1 is our last blue to burst? Or 5 or 8? Because in this way, it is really easy to calculate, and the time complexity can become O(n) cubic. So for example, what if we burst this 3, and this 3 is to be the last blue to burst? So how should we calculate? So basically, we need to use this 3 times this one and times this one. Why? Because all others has already been burst, because 3 is the last. So this means 3, if we can use a left pointer and right pointer to point it to this 3. So this is the L pointer, and the I pointer pointed to 8. How should we calculate? So it should be easy. So if we wanted to calculate this 3 is the last. So it should be nums I times, so nums I is for this 3. And then nums I should times nums L minus 1. Because L nums L minus 1 is this number 1, and we still need to times this one, so this one is nums R plus 1. Nums R plus 1. So this is the value we get for the current coins we get collected, this number of coins, but what left behind? So this is for this number 3. We got a coin, yeah, if it is in the index of I, yeah, I just use 3 as an example, but it can be 1, 5, or 8, yeah, maybe it is 5, yeah, we still use this formula, nums L minus 1 times nums I times nums R plus 1. Yeah, because even if it is 5, it is the last blue to be burst. What left behind is only this one and this one. And at the left side and the right side, those ones are just borders. It didn't mean blues, just borders. It means this 5 is the last. So 5 needs to times this one and this one. So this is why nums L minus 1 and nums R plus 1 times nums I. Yeah. And then we need to check what left behind. Basically, I'm going to use the DFS. So what left behind is, so for example, if we burn 5, so this is I. What left behind is 3 and 1. What is 3 and 1? It is L to I minus 1. Yeah. Left behind is L to I minus 1. And we need also to plus this. So what about we burn, yeah, 5. So what left behind is 8. So how should we represent 8? So 8 is I plus 1 to R. Yeah, it is R plus I plus 1, I plus 1 to the right side. Yeah, because this R and I plus 1, it is always included, and this R is included, and this L is also included for my DFS function. Now let me try to use the DFS to solve it like this. If you understand currently, if you understand this one and this one, basically it should be easy. But how should you calculate what's left behind? The subproblem. Actually, this is the DFS recursive function. You can always calculate the subproblem. For example, if you calculate 5 first, yeah, even you calculate this 5, you didn't change the arrangement of the array. You just use these values here and here. It means you didn't delete any numbers inside the array. So the array is stable. So this means you can always use DFS to calculate. Yeah, if you calculate 5 first, the 5 is the last blue. So yeah, what you're left behind is 3, 1, and 8. So let's check the 8. So for this 8, how should you calculate? You can use this 5 because 8 is currently this 8 will burst, but this 5 is the last. This means you can use this 5 as your left border, and you can still use this one as your right border. So it means it always works. So for example, if you want to burst after you burn 5, yeah, 5 is the last blue needed to burn. So what's left behind is 3, 1. It means 3, 1 will burn first before this 5. So it means this 5, you can still use it as a border, and this one is still a border. So this means even you use DFS, you didn't change the arrangement of the array. You didn't change this array. This is why you can calculate, yeah, using DFS, and it is just n cubic. Yeah, let me first write the function, and then analyze the time complexity. So basically, I'm gonna use a cas, and then I'm gonna define a DFS function. So it should be from the left to the right, and inside I'm gonna give a path first. Now I'm going to call the DFS. So the DFS should be from the left side, it should be pointer 1, because this is just a border. Yeah, even for the nums, I will do some preparations for the nums. I mean, no matter which method, maybe you can think about prepare the nums like this, because this is just easy, just easy for the calculation. So you should need to put a left side and right side. You put a 1 at the left side and put another one at the right side inside your nums array. Yeah, so you need to call for the DFS. It is from this one, this L to this R. So basically it is 1 to len of nums. Yeah, if you didn't pad this one, you're gonna use the nums minus 1. Now you pad a number It means you're gonna use the nums length of nums minus 2. Yeah. Now we are going to check for the DFS function. So if the left pointer is more than the right pointer, it means it is out of a border. We need to return a 0. So this situation is this L is here, R is here. So what if this L is here and R is 5? It means it is out of border. We cannot check like that. Yeah, it is just some edge cases. So if it is not like that, it means we can still collect the coins. Yeah, if L more than this R, it means we cannot collect the coins anymore. Now we can still collect it, but how should we collect it? We're gonna use a for loop. So for I in range, because we don't know from which place we're gonna burn the blue. Yeah, burn the blue first and collect the coins first. Yeah, so we're gonna check from the left to the R plus 1. Yeah, so for here, this problem becomes similar to the cutting stick problem. Cutting stick is easier than this one because for cutting stick, it always becomes a smaller array. You can always use L pointer and R pointer to calculate. But for the burst blues, actually you need to think about the representations of this number. So for this number, you burn it. Actually, it is the last to burn. Yeah, if you burn it first, you cannot. Yeah, you have to use a brute force. You cannot solve it. You have to burn it as the last blue to be burst. Yeah. Now let's check. So for I in range this L to R plus 1, we're gonna have, yeah, from the beginning I'm gonna prepare a result. It is 0. Now I'm going to update this result. Should be the maximum of result with the value. So actually it is here nums L minus 1 times nums I times R plus 1 and plus this value. Yeah, it's exactly the same. So let me put it inside just for saving some time. Yeah, so this result is updated. Now I just need to return this result. Yeah, now let me have a double check of this if it is right. So this is what the coins we collected. This is the sub problem. Now it seems okay. Let me first run it to check if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass for all the testing cases. This one normally can pass because we used L and R pointer. It didn't consume too much memory. Yeah, let's check the time. Yeah, as you can see, it passed. It's nearly 5 seconds and 67% of all Python 3 submissions. Now let's analyze the time complexity. So for analyzing the time complexity, actually, this is similar to cutting sticks. So this L and R can be any combinations for the length of the numbers. So this means it is n squared. N is the length of nums. Yeah, this LR just means which kind of numbers we can choose. So this is basically pointers, L pointers and R pointers. It can be any combinations. It is n squared. And here we have another for loop. So the for loop is from L to R. It means basically it is another n. So n squared times n, it is n cubic. So the time complexity is n cubic, but the space complexity is still O(n) squared. Thank you for watching. If you think this is helpful, please like and subscribe. I will prepare more Leetcode problems like